Okay, we are now going to draw vectors to scale at angles, and as you can see by the problem here, we're going to use a scale of 1 centimeter equals 4 meters per second to represent a velocity vector, which is 20 meters per second, and the direction is 25 degrees north of east. I would recommend that you pause the video, make sure you have a ruler, centimeter ruler, and a protractor handy, and see if you can do this on your own, and then turn it back on, and we'll see how we do it. Okay. The first thing we're going to do here is find out what the length of the scaled vector is going to be. The scale is 1 centimeter is 4 meters per second. We're converting 20 meters per second. And we treat this like a unit conversion. I use the scale that they gave us. I'm going to first of all put in units to convert this to the right length. I'm going to put meters per second in the bottom and centimeters in the top. That's going to cancel the meter per second, give me centimeters. Then I look at the numbers. I got 1 centimeter is the same as 4 meters per second. Then I do the math. I notice that the units cancel. That makes me happy. 20 divided by 4 is 5. I'm going to have a 5 centimeter long vector when I'm done. The next thing I have to do is get the right direction. Now, we use this language where we're always giving an angle, and then we say direction of other direction. In this case, it's north of east. I'm going to remind ourselves that the word that comes after the of, the direction after the of, when we say north of east, is the reference direction. So that's where we're going to measure with respect to. So to do this, I'm going to give myself a little more room here. Put my ruler out of the way there. I'm always starting a vector at point P, so here's my point P. And then I need a reference direction. The reference direction in this case is going to be a direction that is east. So I'm going to make a dotted line which goes through point P and points east. So I'm going to line it up with point P. The arrow at the end of the dotted line I don't really care to have. It's just the tool that I have on this board. It makes me have an arrowhead at the end. I don't really need that. All right, my reference, I'm going to make point P a little bit more pronounced here so I can see it. This points east, and I might label it as such. Okay, that's my reference direction. And I need a vector that is 5 centimeters in length. I've already done that. And the direction is going to be 25 degrees north of east. All right, where is north of east? Well, if I look at my standard directional weather vane, which was already provided, we just hadn't seen it before, north of east means that I want to basically take my vector, and I'm going to sketch this first. This is not to scale. So my vector is going to be pointing this way, and I want to move that direction 25 degrees toward north, that's north, from east. So I basically want the direction to be somewhere roughly in here, because that's about 25 degrees north of east. Of course, what I'm going to do now is measure everything, so it's within 2 degrees of the right angle. So let me get rid of this, and boom, and let's bring the protractor over here so I can actually measure this properly. Now, using a protractor, every protractor is different, and the one point on the protractor I have to find is the point here. I don't know if I can draw over this thing or not. Looks like I can. Right there between this, between the 0 on this side and the 0 on that side. Find the zeros on each of the protractor. Exactly midway between them, you're going to have a point which might be a crosshairs like this. It might be a dot. That's the point that you want to line up with point P. All right, let me get these arrows out of the way. And I'm going to bring the protractor in here so that that dot is right over point P. All right. And I want to make sure that this 0 line is lined up with my reference direction, which it is. So 2 things. I've got that little crosshairs, boom, right over point P. And I don't know what the heck this thing is. Maybe it's an angle. And so now I want to go 25 degrees toward the north of east. Yeah, looks like I can, this is cute. All right, so I'm now 25 degrees. I've moved my angle 25 degrees north of east. Now with a regular protractor, you don't have this nifty graphic here. So what you're going to do, if I can move this thing out of the way, what you're going to do is just put a little tick mark here, which I can't do very well, because it thinks it wants to know where I want to draw. Okay, okay, so there's my tick mark. I'm basically trying to put a tick mark at the 25 degree mark where I've counted 25 degrees north of east. And again, with my cool graphic here, it looks like that. All right, if I get rid of the protractor. Well, I get rid of the protractor, I just still have the mark that I made. And this is a key thing. I now want to bring my ruler in here, and I'm going to rotate my ruler, which I can do some clever way. There we go. I'm going to rotate my ruler until it's lined up with that tick mark that I put. So the ruler goes through point P and to the tick mark, and I've got the 0 mark at point P. Now I'm ready to draw this vector. I need to draw it 5 centimeters in length. 5 centimeters in length. And that's a perfect 5 centimeters. And then I'm going to get rid of the ruler, turn this into an arrow to make it a vector. Without the arrowhead, it's not a vector. I will label the 25-degree angle, because I measured that very carefully, and I will label this with the magnitude of the vector, which was 20 meters per second. Meters per second. I am done. I am happy.